Let me just load up the slide. Let's have a thumbs up for anyone who can see the lesson goals that we're going to cover today. Good. Fastest fingers from Stephen, George, Greg, Yinka, Lisa, Calvin, B, Stacy, Krug. I don't think I've ever seen so many people so keen to get on with the lecture. It's beautiful. Well done, everyone. Okay, so today we're literally going to be talking, it's going to be an introduction to cloud computing, some of the cloud computing concepts. Okay, we're not going massively deep because we only have 2.5 hours to basically cover it. So we're literally going to go through some of the fundamentals and the concepts that will give you a fantastic grounding for any conversation you have in an interview. So we're going to talk about cloud computing concepts, uses, different cases, the difference between the types of models that we have in cloud computing. There are different models and different types. And we're going to recognize some of the major features on those particular concepts. So without further ado, what is cloud computing? Okay, cloud computing is generally computing. We know our computing at home. Okay, you sit at home, you have a physical desk, you have a physical computer. Cloud computing is where we hand a lot of that responsibility over to someone else and we push it up to what we now call the cloud. What it gives us, the benefits of basically letting someone else look after that infrastructure and stuff. It becomes more of a cost-effective way. It becomes a subscription model. So we're only paying for what we're kind of using. So, a simple comparison is if I bought a desktop here, I've paid for that desktop. I'm using that desktop 20%, 10% of the time. Rest of the time, it's kind of turned off. Okay, so I've already paid for it. Okay, with cloud computing, if you only use that computer for 10% of the time, 20% of the time, 50% of the time, that's what you'll end up paying for. And there are different models and different subscription types that we can basically have. But it also allows us to scale to meet that organization's need. So it allows us to scale to meet my need. So a good example there is if I wanted a second computer, well, I'd have to go and buy a second computer if I wasn't doing it on the cloud. If I do it on the cloud, I can simply go, well, spin up another virtual machine for me. All of a sudden, I've got 2 computers now. And again, 3, 4, so I can scale it up and I can also scale it down. So if I don't want to run 5 machines anymore, 5 virtual machines, I can simply close off 2, 3 of those virtual machines and I'll only end up with 2 virtual machines basically getting run. So there is a lot of tools basically inside. We have applications, we have platforms, and we have the physical infrastructure. The applications are things that will monitor the way our cloud is basically performing. They will look after our content, our web pages, our collaboration material, and communication and finances. These are sort of applications that will run on the cloud platforms. Platforms are things such as our object storage, our identity, our runtimes, our quotas, our databases. That kind of all drops into what we consider the platforms on there. And then there's the infrastructure, which is kind of our compute power. How much processor power do we need? How much RAM do we have? How much storage do we have? Physical block storage. You mentioned block storage. We're going to talk about different types of data storage later on in this lecture. And indeed, how much network traffic. Network traffic is very important for cloud-based computing because, of course, we are dealing with something in the cloud that is moving data, images, and everything from A to B, whether or not that is in a web platform or whether or not that is in a database doing some crunching and some hard work. It is basically all around that network infrastructure. And of course, we can access this from things such as phones, tablets, desktops, laptop servers. We can access it from all those different items. So it's kind of like just having something you can kind of turn on and off whenever you fancy. So NIST, our good old friends NIST, National Institute of Standard Technologies, kind of made a beautiful definition of it. It is on-demand self-service. So I pay for what I want, and I kind of get for what I'm paying. So I kind of want more, I pay more. If I want less, I pay less. It's sort of on demand. You can spin things up when you need. Broad network access is demanded as well because I need to be able to access everything. I even need to be able to make my platform available to all my users or to certain groups of people. But we need broad network access, and that network access needs to be scalable. It needs to be able to go up, ramp up and down with the usage that we have. And one of the key fundamentals that we get through is resource pooling. Okay, because I'm not responsible for the hardware. I'm not responsible for the individual servers or anything like that. Someone else is. that server essentially can be shared as a shared resource between multiple companies. Here's a little guess. Does anyone know what their processor is currently running at the moment? How fast and how much processor percentage they're running at the moment? Smash it into live chat if you know what it is. Is that 3.4%? What processor utilization do you have? If you're on a Windows machine, it's off Task Manager. Wow, my processor is pretty busy, isn't it? Does anyone know what theirs is currently running at? Feel free to smash it into live chat. 7%. Sounds about fair. My machine is actually running quite a lot here. 5% for Sunil. My memory is at 60%. God, I probably need 6 more memory. Probably do a bit less work, I think, is the idea. I can see Stephen typing there. Oh, Stephen's got a Ryzen 5. I like the Ryzen ones. Very nice. Yinka's still typing. Let's let Yinka finish what she's typing. Oh, and a couple of others are typing. Just sort of after the percentage that you're using there. 23% for Yinka, 78% memory. Let's see if we can get a couple of others in there. 23% from Greg. So as you can see, with our systems, and this is just us running from home, so you can see there, 79% CPU from Bertrand. Gosh, you're running a lot of fun stuff in there, aren't you? So resource pooling allows us to make use of that extra resources. If I'm only running 22% on my processor, well, hold on, what am I doing with the other 78%? I had to check my maths there. What are we doing with the other 78% of my resource? Well, why don't they slice that up? Why don't they say, well, I can give 20% to you, 20% to Joe, and all of a sudden now I'm running 3 machines with only the cost of 1. We do the same with memory and we do the same with disk space. Okay, so you can see straight away resource pooling makes the module idea a lot better with virtualization. So I can basically run more stuff on less physical hardware. 20% from Calvin. George is only running 5 to 10. So you can see resource pooling will make things certainly much more efficient on the systems. Not only on that, what we can do is we can do rapid, what's known as elasticity. And we'll talk about scaling ups and scaling sideways, scaling ups and downs and scaling sideways later on in the consultations. But the idea is that we can rapidly scale. We should be elastic. We should be able to go, we want more compute power now. Click a few buttons and we've got more compute power. And same way, we should be able to go down as well. We should be able to drop down the amount of compute power. We should be able to say, I would like more memory. And bang, you've got more memory. So it's got to be elastic. Rapidly elastic is the important word because we want to go up and down as we like. We don't want to be stuck to any particular thing. And it also mentions that it needs to be a measured service. So cloud systems need to automatically control and optimize resourcing by leveraging essentially metered capacities. Okay, some of these are abstract, some of them are real, but depending on the service that you basically have, you'll basically get to pick and choose things such as storage, processing, bandwidth, activity in terms of active users that are on there, as well as your network resources. So there's a discussion question there for us in live chat. What are some examples of businesses or industries that could benefit greatly from rapid elasticity, on-demand self-service, and resource pooling? What business examples do we think would benefit from that? See a couple of you typing in there. That's fantastic. content delivery services. Ian, are you talking about products like Netflix, Amazon? Perfect. Yes, Netflix. We know Netflix. You know, when they have a big release or they have, particular busy times and quiet times, yes, scaling up and down for them in terms of their service is going to be fantastic, because they're only going to pay peak when people are watching peak, when they are getting the peak money in. And when people are asleep in bed and no one's watching Netflix, then of course they can lower their capacity, stop paying for it all as well. Baked subscription platforms. Yeah, exactly. Like Prime, Luna, Netflix, Gmail. Photography. Not sure where we're going with photography there, but there's probably a reason in there. Retail is one. Greg, yeah. When people wake up and they decide to buy things. One of the classic examples is ticket sales. You know, years and years ago, ticket sales used to be an issue, didn't they? A ticket comes out, bang, all of a sudden, the latest Take That tour. Sorry, I shouldn't have done that. Tickets, or so Take That basically come out, the latest sales, bang, and all of a sudden the systems are swamped, aren't they? Okay, well, we'll put it in the cloud, we do auto scaling, and all of a sudden we'll get more and more systems will spin up to handle all those requests, and therefore we're elastic. When the last ticket's gone, well, we don't need that 4,000 servers that we basically put up all of a sudden. And all of a sudden the system will go, right, we don't need them, bang, and it'll crash it all back down. So we only pay for essentially that auto scaling for what we are using at times. That's a good description. Thank you very much, people. Of course, VR, that's very data hungry and fluctuates. Yes, fluctuates wildly depending on who's using what. So we've got what cloud computing. We're going to have a little watch through this video. And as you know, I would have instantly shared the page without actually giving the sound. So let me make sure I turn the share sound on. So thumbs up first. Fulfillment by Amazon to keep track of the orders. Yes, there's always that way, isn't there? I can see several people typing. Let's see if we've got some other comments in there before I pause the video. Something like it. Okay, thumbs up if you can hear the sound on this then.
Imagine you're the owner of a small software development firm and you want to scale your business up. However, a small team size, the unpredictability of demand, and limited resources are roadblocks for this expansion. That's when you hear about cloud computing. But before investing money into it, you decide to draw up the differences between on-premise and cloud-based computing to make a better decision. When it comes to scalability, you pay more for an on-premise setup and get lesser options too. Once you've scaled up, it is difficult to scale down and often leads to heavy losses in terms of infrastructure and maintenance costs. Cloud computing, on the other hand, allows you to pay only for how much you use, with much easier and faster provisions for scaling up or down. Next, let's talk about server storage. On-premise systems need a lot of space for their servers, notwithstanding the power and maintenance hassles that come with them. On the other hand, cloud computing solutions are offered by cloud service providers who manage and maintain the servers, saving you both money and space. Then we have data security. On-premise systems offer less data security, thanks to a complicated combination of physical and traditional IT security measures, whereas cloud computing systems offer much better security and lets you avoid having to constantly monitor and manage security protocols. In the event that a data loss does occur, the chance for data recovery with on-premise setups are very small. In contrast, cloud computing systems have robust disaster recovery measures in place to ensure faster and easier data recovery. Finally, we have maintenance. On-premises systems also require additional teams for hardware and software maintenance, loading up the costs by a considerable degree. Cloud computing systems, on the other hand, are maintained by the cloud service providers, reducing your costs and resource allocation substantially. So now, thinking that cloud computing is a better option, you decide to take a closer look at what exactly cloud computing is. Cloud computing refers to the delivery of on-demand computing services over the internet on a pay-as-you-go basis. In simpler words, rather than managing files and services on a local storage device, you'll be doing the same over the internet in a cost-efficient manner, Cloud computing has two types of models: deployment model and service model. There are three types of deployment models: public, private, and hybrid cloud. Imagine you're traveling to work. You've got three options to choose from. 1. You have buses, which represent public clouds. In this case, the cloud infrastructure is available to the public over the internet. These are owned by cloud service providers. 2. Then you have the option of using your own car. This represents the private cloud. With the private cloud, the cloud infrastructure is exclusively operated by a single organization. This can be managed by the organization or a third party. And finally, you have the option to hail a cab. This represents the hybrid cloud. A hybrid cloud is a combination of the functionalities of both public and private clouds. Next, let's have a look at the service models. There are three major service models available: IaaS, PaaS, and SaaS. Compared to on-premise models, where you'll need to manage and maintain every component, including applications data, virtualization, and middleware, cloud computing service models are hassle-free. IaaS refers to infrastructure as a service. It is a cloud service model where users get access to basic computing infrastructure. They are commonly used by IT administrators. If your organization requires resources like storage or virtual machines, IaaS is the model for you. You'll only have to manage the data, runtime, middleware, applications, and the OS, while the rest is handled by the cloud providers. Next, we have PaaS. PaaS, or Platform as a Service, provides cloud platforms and runtime environments for developing, testing, and managing applications. This service model enables users to deploy applications without the need to acquire, manage, and maintain the related architecture. If your organization is in need of a platform for creating software applications, PaaS is the model for you. PaaS only requires you to handle the applications and the data. The rest of the components like runtime, middleware, operating systems, servers, storage, and others are handled by the cloud service providers. And finally, we have SaaS. SaaS, or Software as a Service, involves cloud services for hosting and managing your software applications. Software and hardware requirements are satisfied by the vendors, so you don't have to manage any of those aspects of the solution. If you'd rather not worry about the hassles of owning any IT equipment, the SaaS model would be the one to go with. With SaaS, the cloud service provider handles all components of the solution required by the organization. Time for a quiz now. In which of the following deployment models are you, as the business, responsible for the application, data, and operating system? 1. IaaS. 2. PaaS. 3. SaaS. 4. IaaS and PaaS. Let us know your answer in the comment section below for a chance to win an Amazon voucher. Coming back.
Okay, so what do we think then? Don't have to necessarily answer the question. That's quite a tiny little video basically on the difference between them all. Yink has gone straight in with IaaS. Stephen 1. Yeah. So I think the good demonstration there basically shows that there are different types of infrastructure that you can basically have. So you don't have to have a full infrastructure as a service. You can have platform as a service, or you can have software as a service. And the key takeaway from that is really looking at the different models. I will appreciate that video, I think, is basically produced by someone who loves cloud. And probably not someone who really hates running their own infrastructure. There is a difference in cost between the two. Some of it falls into the fact that, and we'll talk about it later, whether or not your expenditure falls into your CapEx budget or your OpEx budget. And we'll talk about that right at the very end of the lesson, so I won't go into a massive detail here. But there is obviously an economy of scale involved, isn't there? If you go into a big company, they basically have lots of security experts on there. So their security is going to be tighter than if you're just setting up your own company, running with one security expert, whose also job is actually to look after the network infrastructure and install the servers, because he's not focused on everything, is he? And when he's off sick, well, who's looking after security? So there's an economy of scale in there as well. And that, of course, works with all our shared resources, such as our processors, our memory and our storage space. If we have to buy it ourselves, yes, physically we have to buy it. Cloud is fantastic for new startups, for new companies coming on the board, because they do not have the capital basically to go in and say, we're going to buy loads of stuff. They literally just want to borrow loads of stuff, and they will basically use a PaaS system, so platform as a service, where they create their application, and then they can release their application. Well, they've had to do none of that messing about, getting an IT expert in, a security expert in to install their servers, set up the data networks, control everything like that. They can simply go, well, we just want to play with our toys, and we basically want to create applications. So it is fantastic to do that. And of course, you can rapidly scale. So if your company is successful, you grow and you grow and you grow, and you get more and more. But also, on the other hand, if your company hits a little bit of a hard time, yes, you can shrink down your expenditure by reducing your expenditure on PaaS or IaaS or SaaS that you're basically using. So you've got that expandability to work with your resources within your certain financial limits. Anyone got any questions about that particular video or what we've discussed so far? I can see Stephen typing now. What's it like maintaining those different systems? If you were, in terms of the cloud systems you're asking about, Stephen, or in terms of managing your own infrastructure? Cloud in the data center. If you are a business coming in to look at it, managing those systems depends on which one you go for. If you're going for infrastructure as a service, of course, you're essentially in charge of installing the operating system. So they give you a virtual machine, you drop your operating system on it, you then load your databases on it, you then load any of your applications onto that virtual machine. Okay, so you have to manage those. The flip side of that is it gives you a lot more control over what you're doing. So you control the operating system, so you know what's on it, you basically get full control over it. But you get to manage it all. Now, of course, when you drop into doing something like PaaS, which is platform as a service, well, you don't care. You don't want to know about the operating system. All you want to do is play and write your toys. Looking after those, they are given to you in terms of scaling up and down. You have very nice web portals, graphs, charts, and everything like that, where you can simply go into your account and you can click to add and remove items from your systems. You can spin up servers really quickly simply by going to your virtualization area, depending on which platform you're using, and you can very happily spin them up and you can add them to different networks. So it is massively controllable, is probably the way to look at it. Rather than physically wandering into a server room, picking a server up, sliding it into a rack, and mounting it, plugging all the cables in, you're very simply going to your control panel and you're going, yeah, I want another one of those. You click the button and it says how much processor do you need, how much RAM do you need, how much disk drive space do you need for it, and you can click all those answers and you go bang, there you go, and then you load your operating system onto it. So it is actually really easy to manage those things. How is it from the technical point of view? Yeah, I'm hoping I've kind of answered that one for you, Stephen. Did I get that from the technical point of view? That's if you're a customer. If you're working in a data center, then of course things are slightly different because we turn that on its head, don't we? We can see Stephen typing there. Let's see what he comes up with. It's a very good question, Stephen. I do like that. Okay, if you're working in a data center, so you're now looking inside out rather than outside in, then you are doing all the stuff that you would normally do in an infrastructure team. Okay, so if you had your own systems, then yes, you're doing the same sort of thing. You are physically racking servers. If you are bringing a new set of racks on board, you will be given a spec in terms of what needs to go into which particular U in that rack. You will then go and get all those items. You will then basically slide them in. You will power it all up and turn it on. And your job is to make sure that those things basically run and function as properly as they should do. And obviously, we spoke a couple of weeks ago about the monitoring within the data center. So you monitor those big boards, and when systems start flashing red or yellow, then it's your job to run around and make sure that those systems, either physically you have to go around and change some things, or it could be you need to modify some of the VLAN networks to try and improve some network capability, or make a few different connections, or possibly you are swapping disk drives out. So if you're wandering around a data center, yes, you're looking at it from the inside out. So you're physically doing a lot of hands-on stuff with servers, switches, top of rack switches and things like that, aren't you? Does that answer that question for you, Stephen? Good. And most of the time you are very simply working on tickets and looking at the board that basically shows how the network, the entire network infrastructure there is basically performing. And that shows you how your network traffics are performing, how your databases are performing, how your storage is performing, and how your compute side is performing. And you'll have an idea of how things are basically running. I guess that's really some of the jobs we're kind of looking for, isn't it? Is to drop into a NOC center. Great. So let's have a look at some cloud computing user cases. So we say basically we pick different ones for different items. Cloud content delivery. So distributes web content, effectively reduces latency, web pages and images of videos. Yes, if you're developing this, why not stick it on the cloud? Why would I have it on my own infrastructure? If I give it to a cloud provider, that cloud provider, I know full well, will have a diversely routed network solution. So they're not going to have trouble with some guy running a digger through some cables. If you are distributing your web platform internationally, they have what's known as edge services. So although I may develop my web, say for example in New York, and I may be using one of the zones up in New York to basically store my systems, if I'm publishing that to Australia as well, I can have an edge service in Australia that basically replicates that. So the Australians aren't suffering with a massive latency because they're pulling the data from New York. So all this basically comes from the cloud service. I simply turn on and go, I want the edge service. Here's my money. Thing to remember with all cloud services is what you're after does cost you money, but what you can do is fantastic. Okay, so if you're making money, it's great. So data storage and backups. Okay, these are really easy. We can do long-term, short-term, and they do things like cold storage backups, which are things you basically hide, and they reduce the cost of those. So if you put something into a cold storage backup, it's going to take you longer to get it out from the cloud service, but it's going to cost you less money. Whereas if you want something that's hot and live, that's going to cost you a lot of money, but it will be instantaneous access. So Amazon does things like S2, S3 services and things like that for different cloud storage for data pods. And we do talk about a little bit about the data storage later on in this lecture. So it's a great place to put it. If your data storage requirements for your backups basically expand and increase, well, if you're basically dealing with the cloud service, you simply go, click, I'll have a little bit more storage, please. And it simply will scale it up. If you're doing that on your own infrastructure, well, strangely enough, you have to go out and get some more disks, don't you? And you have to install that either into a server or another format so it can actually be used. And that may be a SaaS product or something like that, mightn't it? Also, cloud computer cases, big data and analytics. Man, the amount of computer power that is out there now within cloud storage is amazing. Okay, and this allows us to store masses and masses of data and analyze that. So we can do big number crunching stuff. But because it's done on demand, when we run those processes to crunch those numbers, yes, we spin up a bit more compute power. But as we drop off and we kind of finish that bit of research, finish that bit of cloud crunching, we can then turn that amount down, and that then saves us the money. One of the places that's prevalent for this is our AI and machine learning. That takes a massive compute storage as well as compute power. So those two things will burn up lots of cash. But we can do it in the cloud because we can turn it up and down. And of course, when we're not using it, someone else is probably using it. So there's that scalability where we're sharing the resources rather than having to go and buy all the massive computer power ourselves. So those are some example user cases that we've given. Can anyone think of some potential concerns or drawbacks organizations may have when adopting cloud services? Put that into live chat. That's a bit of a discussion question, isn't it? So what concerns would you have if you're moving your stuff to cloud services? Cost. Yeah. Good question. Security. Maybe downtime. Cost and data security. I think, we kind of, network connectivity. We just kind of said, and it was presented in that video, yes, it's going to be cheaper. Potentially, you might save on some certain things. Potentially, it might be slightly more expensive compared to if you've already got half the equipment. So if you've already purchased loads of equipment, you're not physically going to move that to your data center. So if that equipment is now redundant, well, what do we do with it? It's redundant. So that's essentially an expense that we've already incurred that we're not going to save money on. In the future, yeah, sure, we're going to save money. Security. How secure is my data on someone else's system? We all feel a little bit shy about it, don't we? I'm giving my data to someone else to look after. Okay, so you've got to build some trust. So you normally will go to a trusted company that has some fantastic shiny record for security that knows they will look after your systems. If you've got really sensitive data, you might not go to a local data center and say, can you look after this? That doesn't have a great track record. So yes, security is always a concern. Greg mentions downtime. Is that downtime in the transfer between getting it up and running? Or is that downtime worried about the data center basically dropping the network ball? Yeah, so how long is your downtime basically between going, yes, I want to move my entire infrastructure, bang, across to AWS? How much downtime is that going to have? Well, the honest answer, it should be nothing if it's done properly. If you do the migration properly, it should be absolutely nothing. To give you an idea, Amazon runs several different models of how they will actually transpose your systems and your data across. They will transfer data in a disk drive, essentially. They will give you a super secure disk drive with a code on the front that's electronically locked as well and zipped, and they give that to you, and you load all your data and everything onto it, put it in a post. Amazon will then load it onto the relevant server for you. And then when you're ready, you'll sync it and then you'll cut across. So in theory, it should be no time at all. Snow. Well done, Derek. Derek, here's the next question. What's the next biggest one after snow? We're gonna press Derek here. He's obviously looked at this before. See if he's hunting it up in a web page. Greg's heard of it before, yes. Right, and I'll see if Derek can find it quickly. The other option, and this is on the other end of the scale, so that's for small, that's great. You just throw in a fair few gigs of database up there, that's fine, that's perfect. And the reason we do that is, of course, to transfer that across the internet could potentially take days or weeks, okay, because of the simple size of the data. So it's much easier to drop it onto the drive, post it off, and off it goes. And you've got to remember there's got to be a sync time between your live system and the cloud. And that sync will happen overnight. And then the system will simply cut across and your DNS will simply say, okay, don't point to me anymore. Point to the AWS systems now. And all of a sudden it will come across. Now, the other extreme from Snow is they actually send around a massive truck, and we're talking an articulated lorry. They will drive an articulated lorry into your car park. They will park it up. They will run cables from that articulated lorry into wherever your network infrastructure happens to be. They'll plug it in and they will dump the lot onto the storage systems in that truck. And that can be compute systems as well as storage systems. When it's all complete, all looking fine and dandy, they'll unplug it and they'll drive it round to the Amazon data center. So they will literally turn up with an articulated lorry for you if your infrastructure systems are that big. And of course, again, once the systems are up and running and they're synced, you'll then be able to go, yeah, let's cut it across now. Because remember, most of the data is static data, isn't it? It's not stuff that's changing. There is stuff that's changing, rapidly changing, but the vast volume that you are dealing with is basically going to be static data and items. So it's that big shift that you have to cope with. Okay, let's have a look and see if we can answer a few things. Latency, regional data privacy laws. Yinka smashes one right on the head there. So the sweets for you, Yinka. Yes, a latency, not so much. Okay, because we know within the big data centers, they are designed so that they have massive pipelines that go essentially straight onto easy access for the internet. So they are close to the internet hubs essentially. So the latency with a data center should be relatively small in comparison with what I can get from an internet service provider. But there are regional data privacy laws. With every zone and region you go into, more specifically regions, with every region you go into, the data privacy laws are different. Ours are different in the UK, Ireland's are different, Europe, now we're separated from Europe, are different. So we all have different data privacy laws. That's just within essentially what we used to call Europe, but they are different across the states, and they are different in South America, different in Canada. Okay, they're different out in Thailand and places like that. They all have different data laws and requirements. So you've got to bear in mind the data that you're collecting and you're storing in your particular zone and region has to be applied to the data privacy laws of where it's physically located. A good example is that I cannot take GDPR data, or data that falls under GDPR regulations, from UK people and store it in Thailand. I'm not allowed to, because that is a breach of GDPR regulations, because it is not in the same country. So it does very dependent on your privacy laws and where it basically can live. But it basically mentions loss of data in case of fire and no backups. Okay, in theory, backups should always be available. If you're transferring from your site to their site, you've obviously got your system is running anyway. When it uploads to the Amazon or another Azure example, web services, the idea is that then gets replicated and gets looked after. And we'll talk about the redundancy and resilience later. Stephen's got a very good example there. Costs can add up if you forget to turn subscriptions off when not in use. Yes, and companies are very aware of this. I know Microsoft and Azure, they will have a financial automation AI basically sat in the background running on your system that will monitor what you are using and what you aren't using. So if you go into the financial pages, your billing pages on Azure, there'll be a few little hints in there that we going, oh man, you're underutilizing this particular server, or this database is dead and hasn't been read for a couple of weeks. Do you still need it? So there'll be little hints and tips that will give you a little tap on the shoulder and going, buddy, you're spending money on this. Are you sure you should be? But there is also things such as budgets. So you can set yourself a particular budget. So you can say, for example, my Amazon S3 database should only ever cost me $500 a month. Okay, that's my budget. That's what I don't want to spend over. And I can set a little reminder that basically says, a little warning flag comes up that says, if you get to 75% of that $500, drop me a line. Okay, so you get 75%, all of a sudden you're getting pings in your emails and you're getting notifications on the management boards. Cost Explorer, thank you very much, Derek. Well done. So you get these items that simply will remind you and simply go, guys, you set your budget to 500. Here's a little warning that you might be going over the top. Derek, it sounds like you've done a little bit with AWS. Is that correct? Let's go. Great stuff. AWS, baby. So now I need to apologize for being late. We've just covered some of the basics in terms of what cloud systems are. I'm sure you'll be able to catch up during the lecture, or you can catch up by watching us later. So those are cloud computing user cases. So let's have a little look at shared resources. Why is it so effective? We know that we are sharing the resources on it. We're sharing the storage, the processing power, which is commonly known as compute power, and the networking. Okay, it's cost effective because we're not paying for that entire set of processors. We're not paying for that entire set of memory. Someone else is paying half of it. We're only paying for the piece that we're going to be using. So it becomes cost effective. It becomes scalable because if I want to use more resources, I simply tick a box and pay for more resources. And it's flexible because we can turn it on and off when we want. So as I say, it's a fundamental concept of cloud computing is that you are sharing those resources, but you're also sharing it securely. It's really important that we understand that everything that is done in there is secured. When I am using a particular compute resource, I'm using a particular piece of memory, and I'm using a particular piece of storage, that no one else can access it. I know we say we're sharing it, but no one else can access my data. Okay, and that is all 110% secure is what they try and claim. So there's a big division in terms of who uses what data and what basically gets accessed. And all that security isn't our responsibility to look after. Our responsibility is to make sure that our user accounts have the correct allocation so they can access the relevant things. But it's the cloud service provider, the CSP, cloud service provider, it's their responsibility to make sure that no one else is able to touch our data. It is a lot of partitioning. Yes, it is, Stephen. But we manage this with virtual machines. Remember, we're using virtual machines, so the hypervisor basically separates it all out. And hypervisors are very fussy about who touches what. Anyone got any questions about the shared resources? I think Stephen's still typing there. Oh, that's a good question, Stephen. How does the hypervisor separate a massive amount of accounts? If you think about what a hypervisor basically is, a hypervisor is designed to run separate virtual machines. So the first thing that a hypervisor does when it runs up a virtual machine is it establishes its own little block, its own little security section that is that machine, and it allocates that machine, basically then controls who can get access to that data. Right, if I run up another hypervisor, well, they're not connected at all. If you ever run Oracle VM basically at home, where you basically can run up different operating systems in essentially a small desktop hypervisor, and they're totally separate. You are unable to basically link into those details, and that's the hypervisor's job, is to manage those separately. Now, what you will find is that obviously when you run up several VMs, yeah, I run a VM off an external drive. Yeah, that's fine. So when you run up several VMs, your virtual machines not only have virtual machine capacity, but they have virtual networking. So when you're designing your systems, you don't see this in the background, but when you're designing your systems and basically putting in, you can run several different virtual machines, several different databases, and you run the virtual networking layer under that as well. So my VLANs essentially are controlled by me. So my IP address is just like we talked about with some network stuff. So my networks are controlled by me. Only I can access between those two virtual machines. I can chat, but no one outside can come in because they're totally separate from the network. It's a bit like an air gap, essentially. There's an air gap. There's no connection between that. Well, there's no connection between my virtual networking layer and someone else's virtual networking layer because mine sits over here and theirs sits over there. So it's a bit like we'll call it a virtual air gap is probably the best way to describe it. Does that make sense for you there, Stephen? Great stuff. Okay, so let's have a look at the data center and cloud. How those two things, those two words are really getting very, very synonymous with each other, aren't they? So cloud is a virtual concept. It's a concept, isn't it? Everything's in the cloud. We go, everything's in the cloud. What it really means is that all that stuff is sat in a data center. So the physical infrastructure and the managed services, the cost management, security and redundancy basically lives in the data center. So that's where all the physical material is. Okay, the cloud is that virtual environment around the side that basically you look at and go, that's a concept. I'm going to put it into the cloud, really means it goes into a data center. Now, it could go into one or many data centers depending on your redundancy. So they really are kind of used pretty much together, aren't they? So the data centers play a critical role in supporting the cloud. They really do make the cloud, okay? We've got a nice little discussion question there that says, discuss the potential environmental impact of a large-scale data center and what measures cloud providers and organizations can take to reduce the environmental footprint. Gosh, we must have covered some of that earlier on in some of these lectures, haven't we? As soon as we mentioned environmental footprint. So what are the environmental impacts of a large-scale data center? Greg says the land itself, trees and such. Yeah, where are we going to put it? How many trees do we need to cut down to build this data center? It's going to upset some of the green people, isn't it? Tonight basically it says pulling lots of power. Yes. When we put this data center there, do we have enough power supply for it? Yinka says e-waste. Yes, we do have a certain amount of e-waste that basically gets produced. So we do need to consider where we build data centers. You know, should we just build them everywhere? No, clearly we shouldn't. Stephen says under normal operations, minimal most runoff, renewable like solar, hydroelectric and wind. Well, I think we'd like to think they all run off those, but certainly they're getting more and more into basically running off renewable sources. Yeah, something basically mentions the amount of power consumed, power waste. Of course, there's the water consumption as well with our HVAC systems that get involved. And then, of course, we can throw in things such as, the traffic increase. We've got to drive data center technicians who've got to come to and from the place, as well as our security guards and all those other environmental impacts on there. Well, that's fantastic. Yeah, we've got to consider things such as the backup diesel generators. And they can basically get dirty very quickly, can't they? Okay, so that's kind of jumps over the first hurdle that we said we were going to talk about today. So let's dive into essentially cloud service models. Now, we kind of mentioned a little bit in terms of what they basically are in the video, which was fantastic. So I think we might be able to breeze over this fairly rapidly. So infrastructure as a service. Okay, this model basically means that you are in charge of the majority of stuff other than the hardware. Infrastructure as a service, you're in charge of the operating system and upwards. So the operating system, applications that get loaded, the drivers, and the network connection end of things. Platform as a service, so PaaS, is basically designed so you don't have to worry about the operating system. We just want developers to develop products. We don't want them to worry about what operating systems they're on. So they'll produce it on a PaaS system. And then SaaS. Who can think of a good example of a SaaS product? See a couple of you type in there. Slack, Microsoft 365. Yeah. These are all software as a service. I'm not writing the software. I don't care about it. I just want to use the software. Luna Steam, Prime Video. Yeah. All these are basically SaaS products, aren't they? So the further down that model you get, the closer you get into the infrastructure as a service, the more responsibility you have in terms of how that system runs. But with more responsibility, you get more control. So I can control the operating system. I can control what versions basically run. I can control what drivers get installed. I can control all sorts of different things on there that I might need to. I can control load balancers, networking, storage devices. Whereas if I'm doing PaaS, I don't want to get involved with that. I might not care about that. I just basically want to write my beautiful code. So Netflix is a good example of someone that uses IaaS. So then Netflix as a company basically uses IaaS virtual servers to basically produce their compute powers. Generally, IaaS, you need to put in the most work because you need to do the most maintenance, not the physical server side of maintenance. You need to look after the operating system upwards, don't you? Does allow us to basically do things like the elastic building, as we said. So the computing and networking equipments are available depending on the demand. So we get more demand, all of a sudden more systems get spun up to help us out. So we get that elastic effect. A good PaaS example on here is that Google Apps Engine. So Google Apps Engine is basically a cloud-based platform that allows developers to build and deploy and manage applications. Okay, they don't need to worry about the underlying instructions. Like I said, underlying infrastructure. Put my teeth back in a minute. Google Colabs is basically a collaborative cloud-based environment that allows people to play with Python code. Okay, and they use things like Jupyter Notebook for a bit of sharing. Essentially sharing tools, isn't it? And we've already said some SaaS examples there. You pulled up Microsoft 365, Slack. Gmail is the one they use as an example here. So that's really what it is. So for a company that needs to deploy a new web application, which cloud service model should they be using? Stephen, straight in there, fastest fingers, PaaS. Yes, so we're really going to be using PaaS as a model in there, aren't we? Because we don't care about the operating system. We just want to build a new cloud application, don't we? Thank you, Stephen. So there's several different deployments. We kind of said, yes, we can use cloud, and we've used cloud as a generic model. But we also spoke about things such as a public, private, and hybrid cloud. There is a fourth one in there that wasn't mentioned in the video, which is a community cloud. So as a bit of a recap, public cloud is what we tend to basically see a lot of. It's AWS, Microsoft Azure, Google Cloud Platform is up there as well. So this is where the public can generally go and access that particular cloud service. Private cloud infrastructure is a structure that is dedicated to you, so a single organization, normally managed by a third party. A good example of a private cloud is NATS, the guys who stop the planes bumping together in the UK. They basically use a private cloud because they don't want anyone touching or getting near to their systems because it is super security important for them. And they want to run some weird stuff on there as well. Trust me, some of the stuff is really quite entertaining there. So that is a private cloud where they typically go to a company and go, we want this particular boxes, we want this infrastructure basically set up, sort it out. This is the sort of capacity you want to run. Sunny basically says IBM Cloud is a private cloud. I think it probably is. I know HP Enterprise is a private cloud system. That's basically targeting enterprise level companies. So HP Enterprise. NASA will use a private cloud. Well done, Greg. Yes. And then, of course, there's the hybrid cloud. We know this is a combination of both. Some companies may want publicly viewable systems, publicly viewable web pages and things like that, where they're sharing lots and lots of data. But they may also want stuff that is essentially theirs and secret and on their own. Now, community cloud that wasn't basically mentioned earlier in the video. This is where kind of a group of companies that probably have similar interests may come together and say, you know what, if we kind of bundle in together, we want it kept privately, but we have a shared interest about certain databases, shared reach into certain things. So we might have some community cloud, which means only our group, only these 4, 5, 10, 15 companies will be able to get access to it. So it's not open to the general public. It's just open to us, serves our particular needs. And you may found that in things such as some of the research, scientific research communities might well have something like a private cloud applied. Any questions about those 4 deployment methods then? I can see Stephen typing there. So now, is that just an acronym you like me to talk about? Or is there a question in there? It'd be lovely if there was. Remember, SAP as an acronym can probably mean quite a few things. Stephen asks, how do technicians manage these remotely? Is that specifically for the private cloud or for all the cloud models there, Stephen? Oh, it's as simple as that. My access to my AWS and my Google clouds are simply accessed via the web. I simply pop onto a web page that is my access to a particular area, and I can simply go, yeah, I now want to basically turn things on and off. At the break, what I'll do is I'll try and spin up my AWS or my Azure, and I'll show you some of the main boards. That might help. Okay, so now you seem to be typing some fantastic stuff in there. Is there going to be, are you able to form that into a question, or is it just an example of some community clouds? Samples. Fantastic. So these are all samples of community clouds. I freely admit, some of those I haven't heard of. So this is all basically provided to us by our cloud service providers. Yes, there's 3 general players in there. There are loads of others. Don't get it confused. There are loads of other providers out there. Amazon Web Services, so the AWS, Google Cloud Platform, obviously produced by Google, and Microsoft Azure. So we're going to have a little stroll inside the data center here. So Amazon Data Center, we're going to have a look through one of their massive data centers.
Amazon Web Services is an unrivaled colossus of the internet
Thumbs up if you've got the audio.
age, providing the computational horsepower underpinning countless organizations. From Netflix to BMW, Disney to GE, Tinder to the CIA. It earns tens of billions of dollars a year. And if you've used the internet at all lately, you've probably used Amazon Web Services without even knowing it. Join us today as we enter the belly of the beast and take a sneak peek inside an AWS data center. In stark contrast to its cardboard boxes, vans, trucks, jet planes, and warehouses, Amazon prefers not to brand its vast portfolio of gargantuan data centers. But these monumental server farms are the very guts of the firm's wildly successful AWS, that's Amazon Web Services division. AWS began life at a 2003 meeting in the lake house of CEO Jeff Bezos. The firm had just emerged strong from the dot-com bust, but Bezos' fast-growing retailer was having difficulties setting up and rolling out its own internal server capacity. A scheme promising fast, scalable server infrastructure was duly hashed out, and was swiftly identified, by the more enterprising young guns in the room at least, as a potential spin-off service Amazon could sell on to other companies. Fast forward to today, and AWS rakes in a whopping 60% of all Amazon profits. That's about $50 billion a year. How? By taking on other companies' tech problems in the cloud. If you're a startup in 2021, you no longer need to invest precious capital in vast banks of noisy, expensive servers and battalions of nerds to maintain them. You just rent time on Amazon's gear instead. That's the cloud. When you're busy, yay, you hire more gear. If you're quiet, whatever, you hire less gear. The actual gear in question is jealously hidden from prying eyes by Amazon. Even clients aren't allowed to poke around in the data centers they pay for, and their addresses aren't made public. But here's what we know. Take a typical site in Loudoun County, Northern Virginia. AWS is said to run at least 50 individual data centers in this region alone, covering several million square feet. Believe it or not, Amazon is planning on adding still more capacity in Northern Virginia. For instance, a 100-acre site near Dulles Airport the firm reportedly just shelled out a cool $73 million for. On entry to one such data center, let's say this giant nondescript box next door to a pet resort in Sterling, the first thing we notice is that security is the overriding concern for AWS. There's high fences, guards, and several layers of intrusion detection systems, most obviously cameras. When access is permitted to very limited people for very limited periods, two-factor authorization is required on at least 2 occasions during the visit. If a visit is sanctioned, this is extremely rare, visitors are accompanied at all times by at least one authorized member of AWS staff. Once this so-called perimeter layer is passed, the next stage of the data center is known as the infrastructure layer. This is where crucial systems like backup power, fire suppression, and most importantly, HVAC or air conditioning are situated. To maintain market dominance, AWS data centers cannot be allowed to fail ever for any reason. As such, water, power, telecommunications, and internet links are all designed with full redundancy. And keeping all those servers, as many as 80,000 in a single data center, running requires constant monitoring of ambient temperature and humidity to prevent overheating. If the worst should happen and a fire breaks out, a suite of systems involving water and gaseous sprinkler systems are rigorously maintained and good to go in a crisis. Past the infrastructure layer, and we're finally where the real magic happens, the so-called data layer. Security is even tighter here, with a secretive array of intrusion detection systems and even stricter review process for anybody going in or out. Even if something minor happens, for instance an internal door is held open slightly longer than usual, alarms are triggered. All access points are fortified with multi-factor electronic control devices. If a data breach, physical or virtual, is even so much as suspected, the relevant server is automatically disabled and shut down. These security systems are audited throughout the year according to a robust 2,600-point checklist supervised by external bodies. These external auditors can request access to anything in the data center, from humdrum logs to security footage or even the very cameras themselves. AWS staff are sometimes plucked at random from their shifts and interviewed about topics like the disposal of media, itself a process that's held to exacting and robust compliance metrics. Let's look at the hardware itself. In the midst of all this hypersecurity, it's maybe easy to forget that AWS data centers are fundamentally just enormous banks of servers. A typical AWS data center will hold anywhere from 50,000 to 80,000 servers, running on a combined 25 to 30 megawatts of power. It's said that AWS could quite easily double this size and make even bigger data centers. However, like everything Amazon-related, it's all a question of finely calibrated scale. Distinguished engineer and AWS VP James Hamilton told attendees at the company's reInvent conference in 2016 that beyond a certain point, increasing the number of servers and racks per center no longer lowers the incremental cost. At some point, the value goes down and the costs go up. And in our view, this is around the right number, Hamilton says of the data center size AWS usually goes with. Thrillingly, Hamilton employs the term blast radius to underscore the impact a failure might lead to in a much larger data center, hence the relatively modest dimensions. Still, 80,000 servers is plenty, designed to take in, according to Hamilton, some 102 terabytes of data each and every second. Significantly, the engineer also hinted that the bandwidth within the center is wildly higher even than that. Ever evangelists for vertical integration, Amazon have made great strides in streamlining and perfecting the servers themselves over the years. Unlike other co-location server infrastructure providers, AWS has a much clearer understanding of who will be using its hardware and for what. Removing this requirement to be versatile and generalist has enabled the firm to devise ever more efficient server architectures. When mundane software operations are translated on the hardware or even the very silicon of the chips, this can shave nanoseconds off of processing times. And at Amazon scale, that makes a big difference. Initially, AWS bought servers off the peg, as it were, from traditional suppliers. But steadily over time, the firm began developing its own single-depth servers, exquisitely optimized for airflow in AWS buildings running AWS software. AWS has even developed its own so-called Graviton chipsets since acquiring Israeli firm Annapurna. These Graviton chips, currently in their second generation with a third on the way, use the power-efficient ARM architecture. This represents a break from long-term Amazon partner Intel and its x86 architecture, and is said to give AWS clients 40% better price performance, essentially putting supercomputer-level power in the hands of regular commercial users. In terms of storage, a single standard-sized rack in an AWS center can hold 11 petabytes. That's 1,000,000 gigabytes of data on 1,100 disks. Multiplied, of course, by many thousands of times across many hundreds of data centers all around the world. AWS routers, here comes the science kids, can run custom ASICs or application-specific integrated circuits that support 28 ports with 25 gigabit Ethernet connectivity. This diverges, fun fact fans, from the industry standard 10 gigabit Ethernet and 40 gigabit Ethernet networking speeds, but apparently, according to James Hamilton, offers economies of scale when paired together at 50 gigabit Ethernet. Networking between data centers, essential to provide security and backup for crucial client info, happens over Amazon's own private 100 gigabit Ethernet network, which connects the 25 international regions and 80 so-called availability zones across the vast AWS worldwide network. AWS even lays down its own private undersea cables. But back to our data center. Cooling is an overriding priority, and to minimize environmental impact, AWS, in particular in Loudoun County, Virginia, set out to use as much reclaimed water as possible. This stops the company hogging all the precious local drinking water, which would obviously be a PR nightmare. Loudoun Water, the local utility, are happy to provide this reclaimed water at a competitive rate. AWS pays serious taxes here. But it's worth noting that elsewhere, AWS has installed its own on-site water treatment systems. These prevent pipes clogging up with mineral sediment, which in turn causes costly hassle and delay. And if you think that's crazy, the company has even started developing its own power substations. All those servers use a fair bit of juice, so instead of waiting for slow-moving traditional power companies to develop infrastructure to keep all those all-important racks humming at all costs, AWS simply builds electric substations itself. Day-to-day operations within the data center are described by some ex-technicians as being akin to an ER department for computers. With that much hardware, inevitably things seize up, stop pinging, or require a reboot. Fault finding and upgrading equipment is left to a small army of techs who follow rigorously drilled playbooks that cover almost any conceivable eventuality. Metrics are set by supervisors, encouraging teams to complete tasks quickly and efficiently. Some have complained that the working environment is cold, and it's certainly very loud. In the future, we can expect to see more and even louder AWS data centers come online. From early 2020, a new AWS center opened in the Northern Virginia area alone every 3 months, totaling around 1 million square feet in footprint, and that's just one area. All in all, it's quite the numbers game. What do you think? Do these vast data centers...
Okay, we watched that very simply to show you the scale of things that are going on. And Stephen, you kind of see what they do in a data center, guys walking around, some with jackets going through the cold aisles and that sort of thing. So that kind of shows you what life is really like in one of the larger data centers. Okay, what we got? We're 10 past. I think we'll probably scale up and we'll kind of have a 15-minute break now before we dive into some other bits and pieces about the cloud models. Well, hopefully you've had a chance to have a quick break and we will drop into the rest of the lecture. So we kind of had a little bit of chat around basically what cloud computing is. Google Workspace is a pretty decent example in terms of a SaaS product, so we'll mention that really quickly. Let's have a quick thumbs up, though, for everyone that can basically see the Google Workspace. It's a good landing page to kind of start us off. George, fastest fingers, thank you very much. B, Stephen, Sonai, Yinka, Bertrand, Stacy. Okay, so let's rock and roll then. Okay, Google Workspace is a classic example of a SaaS product. Okay, it is a cloud-based product. It gives us Gmail, gives us Google Drive, Google Docs, Slides. So there's different applications in there, Google Sheets, and a Google Calendar. So it kind of throws a big bundle of applications at us. What it also allows us to do is collaborate with each other. So there's a quick discussion point just to get us back into it. What are some of the advantages of working collaboratively on a cloud service like Google Workspace? See a couple of you typing in there. That's fantastic. But what are the advantages of working in a collaborative cloud-based environment compared to what we used to do? Space apart is irrelevant. Yes, it doesn't matter where I'm located in the world, does it? I can still work collaboratively with someone in Australia, someone in New Zealand, someone in Dubai. And the collaboration allows us multi-functions. Yeah, we can do multiple things with multiple people, can't we? So we kind of drag that side of things. It does kind of give us, I like to refer to things simply as a single point of truth, which is one document that we're all basically working for. Stellar backups and minimum cost. So minimum data loss. It's all kind of rolled into it, isn't it? My machine falls in the toilet. I don't care because the whole lot is in the cloud anyway. So someone else is in charge of managing a lot of those backups. Worth pointing out within Google Cloud, you can take additional backups on top of that as well. You can work from anywhere. Yes, I can be sat on a boat in the South China Sea with an internet connection, typing some email or working on my Google Cloud stuff. So we can see the advantages are there for collaboration, aren't they? So cloud file storage. How do we store it? Yinka likes the real-time collaboration feedback. It's really interesting. Google is one of the leaders in terms of collaborative working in terms of the cloud area. They did some fantastic stuff. We blow people away when I was first in this, simply showing people me modifying a document while someone else is actually changing that document as well. And we're changing it at the same time, and you have a little colored cursor that goes around and shows you where that other person was, and you get their little face at the top right hand side that says both me, Peter, and Jane are modifying the document. And it's absolutely fantastic in terms of doing that. Microsoft kind of went, oh God, we've got to catch up. And they produced Office, the Office 365, which is cloud-based, which is kind of very much there now. And they kind of overstepped things and put into Teams. Microsoft Teams is an ultra uber collaborative tool nowadays. No turning up to meetings in PJs, Victor. Certainly, I have to put shirt on nowadays. So let's talk about the storage files. They tend to break storage into three basic types. There's object, block, and file storage. So object storage tends to be very scalable. It's cost effective, and it can store what's known as unstructured data. Block storage is simply the same as your hard disk drive. It's a good old-fashioned disk drive. How much do you want? This is your disk drive. There you go, sir. And then there's file storage, which is similar to your file system. It's a bit like you're opening your Magic Explorer on your Windows machine. Basically, you're looking at files that traditionally have folders, and they're dumped into different things. What we're going to do is we're going to play this video, and I'm hoping I've shared with audio. So give me a thumbs up when you hear the audio.
Hello, and this is Sunny. Welcome back. Data is one of the most valuable assets a business has, and data storage and data sharing are important business operations. Today I will talk about three types of data storage: file storage or file level storage, block storage or block level storage, and object or object level storage. Each of these data storage solutions has its uses and advantages. File storage. File storage or file level storage stores data in a hierarchical structure. The files are organized into folders and subfolders, or you can say directories and subdirectories. To retrieve a file, to get a file, we need a full path of the file and the file name. File storage is commonly used in hard drives, hard disks, like in our personal computers, and NAS system, network attached storage. File storage uses protocols NFS, Network File System, and SMB, Server Message Block. The file system works best when the amount of data is small and stored on personal computers and business servers, normally for small businesses or organizations. File storage is simple, easy, and inexpensive. Block level storage. Block level storage is commonly used for large and structured files, like databases, applications, etc. The file is divided into multiple blocks, and each block has its unique identifier, ID. Blocks can be stored in a different distributed disk drives. When needed, they are retrieved by their ID and reassembled. It is commonly used with SAN, Storage Area Network. It uses iSCSI, Internet Small Computer Systems Interface, and Fiber Channel, FC. Compared with the file level storage, block level storage is faster and more flexible, but more complex. Object storage. Object storage is relatively new technology and is often used for large amount of unstructured data. Objects have three basic components: ID, unique identifier, metadata, description of the data, and the data is actual data. Object storage is great for storing static content like movies, photos, music, etc. They are easily accessible by HTTP request, means websites. I hope this video is helpful. Thank you very much and see you next time.
So you can see there the three different types of storage basically explained. The last one, block storage, fantastic for videos, graphics, images. A lot of websites will use those because they're accessible via HTTPS. Certainly when I was working for White Label Dating, we moved all of our images basically to an Amazon S3 bucket, chucked them all up there, and that made it super quick for our systems to get hold of those data. Anyone got any questions around the storage types? Careful with the word cloud there, Victor. Victor says, so object-based is for cloud because it's easy to be accessed by HTTP. They're all cloud services, so they're all available in cloud. But certainly if you're going to write a web page and you need to access images or videos or anything that is not sequential, as in just something that is chucked into a bucket, then yes, you would basically use an object-based system and object-based storage. Okay, that's the one where they're basically not really relevant to each other. So I'll store a picture of a cat and a dog. They're in the same bucket, but they're not really relevant to each other. Does that answer that one for you, Victor? Perfect. Okay, great. I can see Victor typing away there. Yinka says it depends on your case. Yeah, very true. It does very much depend on what you're doing. But, a classic example, I wouldn't put a SQL database on a block storage, because SQL database is sequential access and it's a single file. So that would probably end up on something such as a block storage. And if I was going to share a load of relevant files that are related to each other in a file structure, say, for example, I might have an accountancy folder, I might have a HR folder, I might have an IT folder that kind of separate them. I'd end up putting those in a file storage, not a block storage, not object storage, because an object storage, they'd all be scattered all over the place. So my accounts folders, my accounts files will be mixed in with my IT stuff, which will be mixed in with my HR stuff. So that's why we tend to differentiate between them all. Perfect. So I've done enough talking for a minute. What we're going to do is I'm hoping we can break into a couple of breakout rooms. And we're basically going to answer these questions. So in the breakout rooms, what you're going to ask in the individual breakout rooms is, consider these four scenarios in here. So chat amongst yourself. So it's a conversational thing. Unmute your mics, regular chats between you. So for each scenario, determine the most appropriate cloud service model. Is it going to be IaaS, or is it going to be PaaS, or is it going to be SaaS? Okay, and then justify that amongst yourselves. Okay, so for each scenario, you're basically going to discuss that, and you're going to consider the factors such as the level of control and flexibility required, scalability and resource management, maintenance and management overhead, cost consideration, and compliance. And again, we'll probably volunteer one person in each of the groups simply to come back and have a little chat about it. Won't be long, no more than a minute or so, basically chatting about it. So we're going to make this a 10-minute breakout room. 10 minutes may be a bit long, won't it? Can we make it 7? How do you feel about making it 7? Great stuff. Let's pop off for 7 minutes then, and we'll see how we do. I think 7 minutes should be fine. I should work out how to recognize if the breakout rooms are all closed, shouldn't I? Right, yeah, the breakout rooms all closed now.
Yes, they will all close in 7 seconds.
Oh, in 7 seconds. I'll hold my breath for 7 seconds. I'll try
Okay,
not
oh,
I'll
no.
try not to go blue while I'm holding my breath. Good. Okay, so we're all back in the room. That's fantastic. So we had a little chat around those 4 separate scenarios. We'll kind of whip through them because I think, there was a lot of good conversations going around. So scenario 1 is a startup company with a web-based system they are basically building. So we know, hold on, it's a web-based system. They're developing it. So straight away, we can probably look at doing that as platform as a service, can't we? They don't want to worry about the operating system. They don't want to worry about the hardware. They don't want to worry about where the databases and stuff are stored. They simply want to write their application in as easy a manner as it is. And that's what platform as a service is basically relying on. You're allowed to shout out if you have anything different to what I discussed here. Number 2 then. So number 2 is a research institute needs powerful computing, environment to run a complex data analysis and machine learning workload on a large data set. They require direct access to configurable computing resources and storage. So straight away, if they're basically looking to work with direct access to configuring the computing resources and playing with the databases, then we're looking at an IaaS, so information as a service, because they want to control the operating system. They want to control the application that manages the databases. Okay, and they want to be able to scale up and down on this large data set. So again, we'll drop onto IaaS as a system there. You're allowed to ask any questions as I go through. I can see Yinka typing. How are we doing, Yinka? Infrastructure as a service. My apologies. Perhaps I should have had an extra coffee at halftime. Thank you very much. Okay, so the next one, 3, is a large enterprise is looking to migrate its email productivity and collaboration tool to the cloud. So they're looking at migrating an existing solution they've got to the cloud. They want minimal maintenance. They're fed up with that to their provider, and they're going to say, look, just run this for us. We'll just access it. Good, fantastic. Last but not least, number 4. So a media company needs to stream high definition videos on a global audience with minimum latency. So they require a scalable and reliable content delivery solution. I've got 2 potential solutions for this. How many people came up with, let's have a show of hands. How many people came up with PaaS for this one? We have to do live chat now. So show of hands in live chat. I can't see everyone's hands basically in the Zoom workspace. Victor, put your hand down doing live chat. Group 1. So group 1 certainly thought it was PaaS. Could we also offer this as SaaS? Sounds like it could be either, couldn't it? It could be a platform as a service that they're offering, but it could also be SaaS. As essentially, they're offering a streaming high definition video. So, it could be they've already got an application that does it. So I would potentially go, they may be mixing the model. They've got SaaS basically as the end product. That's out there. That's what they're running. And gives them scalability and reliability of content delivery. But if they want to do any more development, they probably want a bit of PaaS on the side for the developers to continue to build and develop that. So it could be a combination of the 2 because they're going to look forwards, aren't they? Okay, well, that was perfect. Thank you very much for taking part in that. I hope you all enjoyed that little section. Now, if I've got my screen shares correct, we'll basically drop on to cloud scalability. Scalability is critical for cloud. It's why we do a lot of cloud, because we can scale it easily. So we do scaling in 2 different ways. Scaling up, which is vertical scaling. Okay, so scaling up deals with increasing the power of a virtual machine. So we're taking one virtual machine. Yes, it may have a multi-threaded 6-core processor on it. Okay, that's not very much. If I want to scale up, I may want to make that 16. I may want to make that 32. I may want to make it even more than that. That is called scaling up. So you're taking your virtual machine, you're making it bigger. You're putting more memory into that machine. Again, bigger and bigger. One machine, scaling up. The other scaling we do is scaling out, which is horizontal scaling. Now, horizontal scaling, we're not going to change the size of that virtual machine. What we're going to do is we're going to put 2 virtual machines in. We're going to put 3 virtual machines, 4 virtual machines, 5 virtual machines. So again, that is scaling outwards, okay, which is horizontal scaling. Now, we use both in different means. Scaling up basically means we've got more processor power doing a particular task. Okay, so if we're doing lots of number crunching, scaling up is a good thing. Scaling out means we've got more services. So for example, if we've got a website that is running where people are desperately trying to book loads and loads of tickets, we can scale that out because we can stick a load balancer in front of it and we can run 50 machines, 50 virtual machines behind that. And our load balancer will simply say, this guy wants a conversation with the service, go to that server. This guy wants a conversation with the service, go to that server. And they load balance it. And that means they're all doing little things, but instead of having one system doing a little thing, we've now got 50 things doing little things. Okay, and that's scaling out, and that can be up and down very rapidly. Now there's auto scaling. Now auto scaling tends to be used more for horizontal scaling. And there's some really good examples of auto scaling in there that allow it to dynamically leverage and scale systems. The system will sit there and it will go, oh, your system's getting a little bit busy. You know, your 3 servers that you had, they're looking a little bit harsh, and I can see there may be a bit more of a peak coming. I'm going to spin up 1 more machine. I'm going to spin up 2 more machines to match the load that basically comes in via that load balancer. So it'll automatically scale it up. Sorry, scale it out to give you more. Patrick, that's right. Scaling up gives you more powerful machines. Scaling out gives you more machines. That's a good way to look at it. So if you're offering a cloud service, yeah, adding more and more little machines to do individual small tasks is a fantastic way to improve your performance. Have you got any questions about scaling out or up, or the auto scaling? See, shall I type it? There isn't a better. They are different for different models. So if you're running a web platform that's basically that is servicing lots and lots of different small requests, like I want to book this ticket, I want to book this ticket, I want to book this ticket, then scaling horizontally out is much better than scaling up. If you're doing a massive amount of number crunching on one particular database, then you are literally running one server that is doing all that hard work. You don't want multiple servers because they'll trip over each other. You want one server, and you want that server to get bigger and bigger and bigger. So if you're dealing with a SQL database, you may scale up rather than out. Can I explain that? I can see you're still typing there. That's great. See, you're still typing there, Sonny. So I'm gonna have a sip of my fantastically strong coffee. Okay, so you said it overworks the system. So the idea of auto scaling is that you will scale according to the load that is required. And when you configure your servers and your systems, you'll tell it to auto scale horizontally, if that's the type of platform you want, or you'll tell it to scale vertically, depending on what you're doing. So the idea is that your server should always be big enough to do the tasks that you're asking it to do. Or you should have enough servers to be able to service all the requests that you're getting in within a certain time frame. I hope that answers that for you, Sonny. Perfect, that's great. Okay, the other beautiful thing about cloud is the availability. Okay, it's fundamental. When we stick things in the cloud, we don't want them to be available 99.6% of the time. We want them to be available 100% of the time. We don't want to have things falling over. So cloud availability is great. We have fault domains. That fault domain is simply a group of hardware and infrastructure components that look after our systems. So as a customer, I don't care if AWS drops one of their servers. I don't want to know about it. I want my system to carry on running. So the idea is they put in fault tolerance so that if that system falls over, my VM is already running on another system. My virtual machine is already there and running. I don't even feel an impact. Okay, this works with cooling, networking, power, all that sort of stuff means there's faulty domains. There's some update domains. So they will break their systems into particular domains where they'll run updates, and they tend to do rolling updates. So they'll look at the systems, they'll go, okay, you know, all our HPDL G8 sys servers need an update run. Well, they don't go, we're going to run an update on everything. They'll say, well, we're going to run an update on this particular domain, and it's free, and all the other systems will carry on running. And then we're going to update the next domain and the next domain. So there isn't one point where they're simply going, guys, we've just taken down the whole domains. We've taken down everything because we need to update things. It will just update particular pieces. Then there's availability zones. Now, zones and regions, I get these, I'll hold my hand up. I get these confused and I sometimes get them the wrong way around. So availability zone is essentially the next level extension. Now, the zones are a group of data centers. We don't just give you one data center. AWS, they've got hundreds around the country. So when I put my application and my data to AWS, they don't just go, that lives in the west side of this database. They go, that lives in this zone. And your zone will be replicated across essentially what is a couple of data centers. So if one data center happens to go up in flames, well, I don't care because it's actually on the other data center. The other data center will pick it up and start running it. Okay, so that gives me sort of a semi-geographical diverse location for my data to live. So in theory, things shouldn't fall over. We then kind of broaden that with the word region. So we have zones and then we have regions, right? The region represents a broader geographical location. Okay, it will contain multiple data centers, each with its own set of zones. So regions happily provide redundancy. So if something goes totally wrong with a particular area, a particular zone, then the region doesn't matter, but you pay kind of a bit extra to say, I want my data, I want my stuff basically spread around a region, and you can basically put it in multiple regions. So I can just have it, I can have it in the North American region, I can have it in North America, West America, Europe. So I can go, well, hold on, let's make it totally geographically diverse. And they can act independently from each other. So if one fails, well, the other one simply picks up the slack. So again, we're pushing towards me never actually having any problems. So let's have a quick glance. I think this is a suitable video. Thumbs up if you get the sound on this one.
Companies are increasingly moving to cloud-based infrastructure to improve agility, gain unlimited scalability, and lower costs.
Thank you, George.
When moving to the cloud, organizations look for the scalability, performance, reliability, and security of the provider's global infrastructure. AWS delivers a cloud infrastructure companies can depend on, no matter their size, changing needs, or challenges. It's designed and built to deliver the most scalable, reliable, and secure cloud computing environment with the highest quality global network performance available today. AWS offers the world's largest global footprint with 66 availability zones, or AZs, across 21 regions. Each region has multiple AZs, separated and isolated from one another, and connected by low latency, high throughput, and highly redundant networking. These AZs offer easier and more effective design and operation of applications and databases, ensuring higher availability, fault tolerance, and scalability than traditional single data center infrastructures. Within each AZ, our data centers have been designed with custom, purpose-built compute servers, storage servers, routers, and silicon. By using its own custom hardware, AWS provides the highest level of reliability and the fastest pace of innovation, all at the lowest possible cost. With 20 years of experience operating one of the world's largest websites, 12 plus years of cloud infrastructure expertise, and millions of customers running every imaginable use case, AWS is uniquely positioned to deliver superior operational performance customers can depend on for their most important workloads. Visit the website to learn.
So that kind of gives you an idea of the scale of things. This is why, if you stick things into AWS and you basically, or one of the other cloud providers, and you break it into different zones and different regions, in theory, you should never lose connectivity. Things should never go down totally. Any questions about zones and regions? I can see some people typing there. Let's see what they've got. I'm not sure where you are. We can basically look up the zones off the website, so we can look at that later. I kind of want to crack through because of the time we've got. We're going to fly through CapEx and OpEx. Sunny, we will look at that later. CapEx and OpEx, okay, not massively important. What you really need to understand and probably need to get a rough grasp on is capital expenditure is when you are buying an item. You're buying a physical server, you're buying a physical switch, you're buying something. So if you're running your own infrastructure, you're doing capital expenditure. The taxman looks at capital expenditure different than it does operational expenditure. Cloud purchases, because we're not physically buying a server to run it on, falls under operational expenditure because this is you running your day-to-day business and therefore is taxed in a slightly different way. That's really for the accountants. We probably don't need to worry about it if we're going to be data center technicians. So there is some beautiful calculations in there. So if we talk about cloud expenditure, there are tools out there that will tell you how much it will probably cost to run your particular operation. So if you're looking at doing a lift and a shift to the system, you can go to the AWS price calculator, click on there, you can tell it what you basically want. And all of a sudden it will tell you, it will say, well, this is how much it's going to cost you a month to run that infrastructure on my cloud. Microsoft does the same with an Azure calculator, Azure price calculator. So it's great. So if you know in your office, in your infrastructure, you've got 4 servers, and you've got 3 databases, you've got this much data storage, you've got this much networking power, smash it all into one of those and it'll go, well, this is what it's going to cost you per month to have us run that for you. And we mentioned budget management. So there are budget managements. The CSP offers a tool that helps you plan your budget and assign credentials and thresholds where alarms will come off if you start pushing towards those budgets. And it will give you some different tools about cost recommendations. So there's actually an advisor engine that works in the background that looks at what you're basically using. And it may say, oh, you're underutilizing this particular server, or you don't need this database, there's not been access. Why don't we move it to a colder storage form of database, which will be cheaper for you? So there's all sorts of help in there to make you to allow you to manage your budgets. I don't know if we've got any questions about money other than where we get it from. Good stuff. Okay. Coming towards the end now. This is fantastic. Cloud migration. There's 3 different types of cloud migration that actually happens. And they're all fairly logical and sensible things. Rehosting is what they term as a lift and shift. This is taking exactly the footprint that you've got. It's not your physical servers, but it is running the software, the servers, etc. So it's taking exactly what you have in your own infrastructure and going, we're going to replicate exactly the same thing on the cloud. Okay, so that is the lift and shift. It's quick. It basically means you are still running exactly the same stuff. So you know what it's like. Okay, it may not get you the benefits of utilizing a lot of the cloud native features. So the benefits of going to the cloud, you may not appreciate because you're probably not duplicating. You're probably taking one virtual server and sticking it onto another machine. So you may not be getting the benefits. Copy and paste, essentially. Yes, thank you very much, Patrick. Then there's re-platforming, which basically means you're looking at what you've got. You're going to lift and shift it. But as you do that, you're going to tinker it. You're going to make a few tweaks. You might introduce auto-scaling into your web platforms. Or one of your SQL servers may have auto-scaling, may have extra redundancy. You may put in a few load balancers. So you're making some tweaks to make it better, to make it much more cloud orientated rather than personal infrastructure orientated. And then there's a refactoring. A refactoring is the big dog. Okay, refactoring is basically you look at what you've got and you go, right, I know what I've got, but this is what I want. You look at the cloud, you look at how beautiful it is, and you look at what it could do, and you think, okay, well, I can bring it across, but I want to do it totally different. I want to totally cloud it. Okay, it requires more time and resources and consideration when you're doing it. But essentially, you're getting a clean slate. You're getting a brand new set of systems that are designed for the cloud environment. And in theory, should make it much more efficient, cheaper, and much more effective for your customers. So those are the migrations. Anyone got any questions about migrations? Fantastic. Let's see if we can basically do some virtualization. Show of hands, who's used a virtual machine before? Alexis, put it in live chat. I can see your hand. You're at the top of my list of people I can see at the moment. Yinka, yeah. So we've all basically used a form of virtualization. So we know the virtualization. So we might whip through this fairly quickly. Although there might be a few people that haven't. So virtualization relies on what's known as a hypervisor. Your hypervisor is the dog that's in charge of all the virtual machines that sit on top of it. You can see an example here on the left-hand side, focus on the left-hand side, type 1. We have our hardware. We have our server, which has processors, memory, and disk drives in it. On top of that, we run a hypervisor with an operating system. So it basically replaces our operating system. It does all the communication between the virtual machines and the hardware. On the right-hand side, there's more of a type 2 hypervisor, which has an operating system. So we would, for example, run this on Windows. So we run our hardware underneath our server, we run Windows Server on top of that, and then Hyper-V basically runs on top of that. Okay, and that hypervisor controls the virtual machines, but that hypervisor reports to the operating system that then reports to the hardware. So on the left-hand side, a good example of the one on the left-hand side is ESXi. Is basically just a straight hypervisor you run straight onto the hardware. Any questions about virtual machines and how they work? Now, there are things such as containers, and we're going to watch this very quick video on containers. Containers are basically, think of them as applications. Is probably the best way I can think of virtual applications, but let's have a little look at how they explain it here.
Everyone. In this video, we're going to talk about the difference between virtual machines and containers. But before we talk about the difference between the two, let's go back and talk about how things were before VMs and containers. So the traditional way that a company or a business operates is by having applications running on servers. And each server would just have one application running, whether that application is running a website, a database, or email. So it would be one application on one server. And this was because the operating system on these servers, such as Linux and Windows, didn't really have the capability to run multiple applications securely on a single server. So with each new application that a company or a business offered, they would have to buy a new server for it to run on. And on top of that, the application wouldn't be able to take full advantage of the server's capability because modern servers today are so powerful that oftentimes the server is only running at 10% of its capacity. So by running one application on one server turned out to be a big waste of money and also on the server's full potential. So to fix this problem, engineers developed virtual machines. Virtual machines allows multiple applications to run on a single server by simulating hardware and software. So for example, if a company had 3 servers running one application each, those 3 applications can be run on a single server by simulating those 3 servers and their applications by creating 3 virtual machines. So now this one server is running 3 virtual or software-based machines. It's running all of the different operating systems and also the applications, such as databases, web services, and email, and they're all running side by side on one machine. So as you can see on this graphic, to build virtual machines, you start off with hardware, such as a server. And then on top of the hardware, there's software called a hypervisor. A hypervisor is what allows one machine to run multiple virtual machines. It's what allocates and controls the sharing of a machine's hardware. Some common hypervisors are VMware ESXi, Citrix XenServer, and Microsoft Hyper-V. And on top of the hypervisor are the virtual machines. And each of these will have their own operating system, such as Windows, Linux, and Unix. And then on top of the operating systems, there's the applications that these machines are going to be running. So as you can see, virtual machines solve the problem of wasting money on new servers. But as great as they are, they do have some drawbacks. And one of them is that VMs can consume a lot of disk space. And this is because each VM has its own dedicated operating system. And because they have their own operating system, VMs also consume a lot of RAM and CPU power from the server that could be used for other processes. And VMs are slow to start up because since they have an entire operating system, they do take time to boot up. And with each VM, it also requires a license for the operating system, which costs even more money. Now let's talk about containers. Now containers are similar to VMs, but the major difference is that where VMs simulate an entire machine, containers only contain an application. A container is an application that's been packaged with all the files, configurations, and dependencies necessary for it to run, which basically means that it's bundled with everything that it needs to run on just about any computing environment without having to add anything else to that computer. So for example, if a developer created a website and they wanted to distribute that website so it can be hosted on just about any other computer, they can create a container for that website by bundling it with everything it takes for it to be hosted on another computer, such as the libraries, HTML code, scripts, web images, and web server software. Then that container image can be distributed and hosted on just about any computer or server without adding any additional software or doing any configuration. The container has everything it needs to run that website all in a convenient little package, which is amazing. And the leading software that is used to create, manage, and run containers is Docker. Docker can run on Linux and Windows machines. So just like VMs, to create containers, you start off with hardware such as a server. And then on top of the hardware is an operating system such as Linux. Now, instead of a hypervisor, containers will use a container engine. A container engine is what unpacks the container files and then hands them off to the core of the operating system, which is the kernel. So as I stated before, the major difference between containers and virtual machines is that each VM contains an entire operating system, which makes their file size larger, which is why they are slower to boot up. But on the other hand, containers don't. The containers share the underlying operating system that's on the server between them. Containers only contain an application, which makes their file size much smaller. And this is why containers are considered lightweight, which also makes them lightning fast. So while VMs can take minutes to boot up, containers take milliseconds. Containers also consume less RAM and CPU power from the server than VMs. Now, both VM files and container files are portable, which means that you can move them easily to different machines. But container files are a lot smaller, which makes them ultra portable. Now, containers do have some disadvantages when compared to virtual machines. And one disadvantage is that the container file or image must be packaged to work with the same operating system of the server that it's running on. So if the server's operating system is Linux, then the container file must be Linux-based. If the operating system is Windows, then the container must be Windows-based. But with virtual machines, this isn't a problem. A VM can run any operating system it wants. Another disadvantage is that since the containers share the underlying operating system between them, that means that if the operating system on the server crashes, then all the containers will go down. So you can clearly see that both VMs and containers are amazing technologies. In fact, some organizations use both of these technologies on the same machine, where they would have a server running VMs, and inside those VMs, they would be running containers, utilizing maximum productivity. But that being said, Docker containers are clearly the future because of their size, portability, and speed. Hey guys, are you tired of
Okay, so that's the difference between virtual machines and containers. Anyone got any questions about virtualization then? Good. I think we kind of covered that before, haven't we? So I'm going to run through a quick conclusion for the course for people that basically need to disappear off. So the conclusion for today, we spoke about cloud computing. We realized what it is. We know it is utilizing a lot of shared resources. And we spoke about what IaaS is. It's simply the infrastructure as a service. So you have to run the operating system as well as your applications. And we spoke about PaaS, which is basically a platform for developers to develop their applications where they don't care about the operating system. They don't care about where the database storage is or anything like that. They simply want to develop their systems. And then there was SaaS, which is software as a service, which is basically just delivering the application at the end of the day. We mentioned things like our cloud file storage, so the different types of storage, our containers, and we talked about the cloud store types, which talks about block and object storing. Anyone got any questions around those particular items then? Right, thumbs up. Let's have a little thing. I said we might show you a couple of, I see Sandy typing, thank you. I mentioned we might show you a little spin round, a web service platform. Thumbs up if you still want to hang around for that. I see Stephen does. I knew you would, Stephen, definitely. I'm not going to go into much detail. Alexis has waved a hand. That's good. Okay, there's a few people coming through. We might as well dive into it. I know we're right on time at the moment. Okay, so this particular one is Microsoft Azure. Okay, this is the platform. When I log in, this essentially is one of my dashboards. Okay, you can create other dashboards. You can do things like your Azure monitoring, which will monitor how your system is. And we can do cost management, and we can look for defenders and a variety of dashboards. We can, of course, go to virtual machines, and we can look at our virtual machine, and we can create new virtual machines. We can create an Azure style virtual machine. And it'll simply ask us questions about what we want. Okay, disks, networking, management, monitoring. I won't go into a great deal of details on this, but this is literally controlling what we are basically building as a virtual machine. We're telling it to put it into availability zone 1. Yeah, we can stick it into a different availability zone, because I think here we're telling it we basically want this to run in Europe. Okay, UK South. I can say I want this one to actually run in the East Coast USA, and I can put it into a different availability zone. Virtual machine scale set, availability sets. So as you can see here, we basically have an awful lot of control. Have you gone through this before, Greg? I can see you did this. So you've already had a play with this virtualization before, yeah? Okay, it was one of your mini projects. That's fantastic. And that's the AWS one that basically does the same. Mini project 2. Perfect. Stephen, is it all kind of coming back to you? This is literally the portal that we go to when we try and control the amount of servers that we have, the amount of virtual machines, the storage that we have, and indeed the networking that we kind of have. So has anyone got any questions they'd kind of like to ask around that?